Smaller stones and rubble fill gaps between foundation blocks. Material is packed tightly by hand. Stability depends on weight alone. Lime mortar is mixed beside the trench. The mixture is thick and slow setting. Binding strength develops gradually.
Watch that beam coming up. All right, secure the base.
Next pole's ready on platform 2.
All right, bring it down slow. Watch the edge. Hold it right there. Perfect.
Increases noticeably. Foundation load continues rising.
Early vertical measurement using plumb lines. Alignment appears acceptable at this stage. No tilt is detected yet.
Stone supply continues arriving steadily. Construction momentum increases. Confidence remains high.
This wall isn't plumb. Look at the gap.
I see it. This needs to be reported immediately. It's still off by ½ an inch right here. We can't pour like this.
Right there. Hold the pour. Tell the crane to stand by.
All right, bring it down slowly. Watch the alignment. Holding steady. Setting it in place.
Look at the joints tightening under the load right there.
It's compressing faster than the projections indicated. It's deviating by more than an inch already.
Yeah.
We have to stop the pour until we assess the structural integrity.
All right, raise it slightly on your side. We need that shim in tight.
Wait, it's starting to tilt. It's not stable.
Back away, move.
close-up of mortar joints on the lower side. Compression causes joints to squeeze tighter. Stress concentrates locally.
Push it over, watch your footing. It won't clear the ledge. We have to angle it more.
Interior view of central hollow internal counterbalance exists.
Plumb line measurement repeated from a higher level. Deviation is now unmistakable. The tilt accelerates with height.
They told us to hold the stone.
What now? Are we done for the day?
Interior internal counterbalance exists.
Plumb line measurement repeated from a higher level. Deviation is now unmistakable. The tilt accelerates with height.
Skyline. The tilt is now undeniable. The engineering challenge is fully exposed.
The plumb bob is perfectly still.
All right, let's get the repairs started. Proceed with extreme caution. That wall hasn't moved in decades.
All right, push it hard. We need to close that gap. Give me everything you got. Move it now.
Notice how the taller courses here create that slight counter curve, essential for stabilizing the upper levels.
As we ascend the famous curvature, the internal geometry continuously adapts to the structural correction efforts. Plumb line measurements are repeated from new upper levels. Deviation is reduced locally.
Overall stability remains uncertain.
Look at this joint, we're starting to drift.
Yeah, I see it.
We need to adjust the alignment before we set the next block.
Ease it in slowly. Almost there. Push the higher side a little more.
Permanently. The lean is locked in.
Construction pauses once more as uncertainty grows. The tower stands partially corrected. Work halts again.
Weathering continues across exposed stone. The tower survives seasonal changes. Settlement slows further. Final wide shot of the tower before its final construction phase. The lean is accepted as permanent. Future work will adapt to it.
Hold that beam steady. All right, secure the clamp on your side now. Watch the wind up there.
Look at that edge. It's migrating significantly.
I see it. The visual check confirms the lean is outside parameters.
All right, take it up. Slowly now, watch the tension on the cables. Easy, easy. Hold it right there.
We need to favor visual balance over strict symmetry here.
A subtle correction on the left course will align it. We need more support on this side.
Move the brace up. Hurry before it shifts again.
Construction of the bell chamber begins at the top. The chamber is lighter than lower floors. Weight increase is minimized intentionally.
Stone walls of the bell chamber rise slowly. Open arches reduce mass. Structural load remains controlled.
Send down the next section. Coming down. Watch it, watch the cables.
Up of base stones under full load. Compression is stable but permanent. The ground will not recover.
Final inspection from a distance. No further construction is planned. The tower is declared complete.
Look at this section here. The displacement readings are already showing movement.
It might be water pressure affecting the sensor. Rerun the diagnostics. The stabilization cables are showing consistent tension across the board.
Good. The structure remains gently restrained as planned.
Wide shot showing counterweights placed on the higher side of the base. Large lead blocks add controlled mass. The lean is resisted mechanically. Tablet confirms the coordinates. Ready to begin extraction on your mark.
Start the process. Monitor the settlement closely.
Check the stabilization on your end.
Make it look weird.
Fully. Balance is maintained at all times.
That wraps up the extraction measurements. Looks good.
Confirmed. Foundation stabilized. Let's pack up. The readings confirm it. The lean is stable.
Excellent. Collapse risk is officially eliminated.
Send down the next section. Coming down. Watch it, watch the cables.